All right, so we're going to be solving equations. Okay, it's something that's useful in any area of math. So if we have d equals rt, we might not want to know what d equals. We might want to know what r equals. So we're going to have to rearrange the equation. So that's what we're going to do today. There's 6 examples. I'm going to practice those with you, and then I'm going to give you examples to try on your own. And if you need help, you can ask me. So let's start with the first one. Okay, the examples get progressively more challenging. So the first one is not too bad. Here we have d equals rt. And if we want to solve for r, that means we need to isolate for r and get it by itself on its side of the equation. Now to do that, if you remember BEDMAS, okay, we're going to use BEDMAS, but in order to get r by itself, we need to undo whatever is being done to it. So right now, for example, r is being multiplied by t. Okay, in order to undo that, we need to first divide by t, right? We always do the opposite operation. Okay, and because we're doing the opposite, we're actually going to follow BEDMAS in the reverse order to be able to do that. So in this case, well, there is no addition or subtraction, but we do have a multiplication. Okay, so let me just write this bigger, d equals r times t. Okay, so if r is being multiplied by t, to undo that, we divide by t. But you can't simply divide by t on one side of the equation. If you do, the equation is no longer true. Okay, so for example, if you had a true statement like 2 equals 2, that's true. But if I divide one side by 3, it's no longer true. 2 does not equal 2/3. So whatever you do to one side, you have to do to the other side so that the equation is still true. Meaning if we divided by t on the right side, we must divide by t on the left side as well. So now on the right side, t divided by t, well, those go away because t divided by t is just 1. And we're left with r equals d over t. Okay, not so bad, the first one. For the second one, we have both multiplications and addition. Okay, and we need to solve for w. So this is where reverse BEDMAS is going to help. We're not going to deal with the fact that w is being multiplied by 2 yet. Right, first, we're going to deal with our addition and subtraction and deal with the fact that we have this 2l over here. So on the right side of the equation, we have 2l. What we need to do is get rid of it. In order to get rid of this addition, the opposite of addition is subtraction. So what we need to do, let me just write this equation nice and big. Right, to get rid of 2l on the right side, we're going to have to subtract 2l. Right, because 2l minus 2l is just 0, so it'll disappear. But again, whatever you do to the right side of the equation, you must do to the left side of the equation. So we must subtract 2l. Okay, just writing that out neatly, we have p minus 2l equals 2w. Now we can move on to multiplication and division. In this case, we have 2w. So w is being multiplied by 2. So in order to undo that multiplication, we do the reverse operation and we divide by 2. But we can't just do that to the right side. We have to do it to the left side. And on the left side, we have 2 terms. When we divide by 2, we have to divide everything by 2, not just p, or not just 2l. We have to divide the entire thing by 2. Okay? The 2's over here will cancel, and we'll be left with w equals p minus 2l over 2. Now if you want, you can just leave it like that. But if you wanted to simplify even further, right, you can have p divided by 2. Just write it over here. P divided by 2, and separate the terms and have minus 2l divided by 2 equals w. You can see you can simplify even further because these 2's will cancel. And we're left with p over 2 minus l equals w. But I would be perfectly happy if you stopped here. Okay, I don't want to go too fast. Let me pause it to see if anyone has any. All right, so for question 3, again, we have a fraction. Now, just like I showed you up here, this fraction here, c plus d all over 2, is the same as we can write c plus d over 2 as c over 2 plus d over 2. It depends how you want to do the problem, and you can approach it either way you want. These two are the same. In this case, it's actually easier to leave it as one fraction, but again, you don't have to. So what you can do is you can imagine, let me just rewrite this bigger, c plus d over 2. When you're leaving it at one fraction, it might be easier to imagine, or even don't imagine, actually write in brackets over the numerator. That way it looks more like a single fraction. And when we do that, we have something over 2 equals q. So something is being divided by 2. To undo that, the opposite operation of division is multiplication. So we're going to multiply both sides by 2. Okay, now it's a little easier to see with the brackets. Again, it's just something in a bracket multiplied by 2 divided by 2. 2 over 2 is just 1. So those are going to go. And we're left with 2q equals bracket c plus d. And now it's probably easier just to get rid of the brackets and view it like this, since what we want to do is solve for d. Right, so in this case, when we're rearranging, we have c being added. So to get rid of it, we want to subtract it. We're going to have to do that to both sides of the equation. C minus c is 0. We're left with d on the right side. And on the left side, we have 2q minus c. Okay. But like I said, you could have thought of it as two fractions. If you like, I can show you that method of doing the same problem. So you have q equals c over 2 plus d over 2. You can split the one fraction into 2. You just have to remember that 2 needs to be on the denominator for both fractions. You can't put it just for one. Right? So now what you can do is if you have 2's on the bottom of each fraction, we can multiply every single term by 2. So q would multiply by 2, the c over 2 by 2, and the d over 2 by 2. In this case, these will cancel, that won't. So we're left with 2q equals c plus d, which is what we had in this step. And then we go make the final step there. Okay. Let me just erase this part so I don't have room for question 4. Okay, so in this one we have v equals 3k over t. And this time they're asking us to solve for t. And t is in the denominator. Okay, well when you're isolating for something, there's no rule that says you cannot move the term you're isolating. Right? Up until now, we've left r alone, and we've left w alone, and we've left d alone. We don't have to leave them alone. Right? If I want, I can get rid of this fraction by multiplying both sides by the denominator. So multiply this side by t and this side by t. And I just threw in brackets there. T over t is 1, so that disappears. And we're left with 3k. On the left side, we have TV. Okay. Now some of you may have remembered that you can do sort of a cross multiplication and just switch the places with t and v. And that's essentially what we're doing, because our next step, we have v being multiplied by t. So to undo that, we divide both sides by v. V cancels on the left, and we get t equals to 3k over v. Let me just pause it. Okay, so in example number 5, we need to solve for s. Okay, again, you can think of it as bringing the 360 up top and the pi r squared down below. But really what we're doing is, let me write it out big. So we have pi r squared s over 360. I'll do it one at a time. So let's look at this 360. To get rid of that, you'd have to multiply both sides by 360, because that's the opposite to division. Those cancel, and we're left with just 360a equals pi r squared s. Now, we're essentially bringing the pi r squared down. And we can do that because what we do is, if pi r squared is being multiplied into s, the opposite operation is division. So we can divide both sides by pi r squared. They cancel on the right, which, we're left with 360a over pi r squared. Yeah, or my 2's bad, sorry. Okay. Moving on, number 6, we need to solve for a. Now a is inside the bracket, so again, if we are doing reverse BEDMAS, the bracket is something we want to deal with last, so let's not worry about it right now. Instead, we want to worry about what's outside the bracket, so we're multiplying by h and dividing by 2, so let's focus on those. So here we have a plus b multiplying by h and divided by 2. Okay, now it doesn't matter which one we do first, the multiplication or division, but I'm going to get rid of the 2 because most people don't like fractions. So 2 is a division, so the opposite operation would be multiplication. So we need to make sure we do that to both sides. On the right side it will cancel, and on the left we're left with 2a. So now we still have a plus b times h. Again, bracket we're going to leave until it's all by itself. So this is being multiplied by h. To undo multiplication, we divide. So divide both sides by h, and on the right, h over h is just 1. So now we're left with 2a over h, and on the right hand side, we're only left with the bracket. Once we're only left with the bracket, we can get rid of it. And we're left with a plus b. Since we're solving for a, b is being added to a, so to undo that, we're going to subtract b to both sides of the equation. So it disappears here, and we're left with a equals 2a over h minus b. Okay, I'm just going to pause there, see if you have any questions.